Volcanic eruptions can be both beautiful and destructive, both at the same time, but now scientists have found evidence that they may also have been linked to plagues and even the fall of the Roman Empire. When a volcano erupts, chemicals are released into the atmosphere in huge quantities, and these reflect light away from the Earth and therefore cause climate change in the form of summer cooling. These chemicals are also locked away in ice, which can provide a snapshot of the timing of an eruption. And now scientists have dated ice cores and the records of summer cooling from tree rings and found that the two match perfectly. Jill Plunkett from Queen's University Belfast was a member of the team that did the work, and she explained how it works to Tom Crawford.
Now that we have much better dating for these events in the ice cores, we can correlate them with other sets of evidence for past climate change and look at the historical records as well. And we can see that there's a very strong correlation between summer cooling and volcanic eruptions. So, for example, of the 16 largest events as recorded in the ice cores, 15 of them are associated with summer cooling.
Did you look at a specific period over the last 2,500 years?
One of the periods we were interested in was a very large acid spike, a series of large acid spikes in or around the middle of the 6th century. So we could see a very large acid spike at 536 AD. The acid tells us that volcanic eruptions occurred, but it doesn't tell us what volcanoes were erupting. So to do that, we have to look at volcanic particles. So when we looked at the particles associated with the 536 acid layer, we found that there was evidence of not just one eruption, but at least 3 eruptions.
And where were these eruptions from?
In this case, it looks as if we have potentially unnoticed, unrecorded eruptions happening. The sources seem to be California, British Columbia, and Alaska. The chemistry most closely matches volcanic systems in these areas. The idea is perhaps that these were relatively small eruptions that haven't been noticed on the ground, but yet their combined effects were enough to cause a large acid spike and potentially climatic change.
And how did you know then that these eruptions occurred at this time?
We can date the ice very accurately because snow is accumulating all the time in the polar areas. So within the ice, there are seasonal changes in the chemistry. And by analysing these changes, you can actually pick out changes from year to year.
I've also heard of things such as tree rings being used as a record for climate.
Yes, tree rings are an extremely good way of looking at past climate change. First of all, the trees grow on an annual basis. So most trees will put on one growth ring per year, so we can date the tree rings precisely to the year. And also the trees respond to the climate conditions that they're growing under. So if the climate is favourable for the trees are going to grow well, and if the climate is not favourable for the trees, you'll get less growth.
And so you were using a combination of the tree rings and the ice cores, and this is what allowed you to get such precise dating.
Before it was recognised that the trees had these periods of unusual growth downturn, suggesting that there was a severe climate deterioration. But they couldn't link them up to the ice core records because the dating didn't seem to be the same. Now, with the improved methods of dating, we were able to show that the extreme events in the trees corresponded with the extreme events, the volcanic events in the ice cores.
So going back to the eruption in 536 with these 3 different eruptions happening, what were the actual effects that this caused?
We can surmise that the summer cooling could have been detrimental for crops growing, and certainly in the historic records we start to see that there are issues happening. We start to see food shortages, famines, and from the 540s we get the outbreak and spread of the Justinian plague. We have a series of volcanic events happening in close succession, and this is likely to have put strain on crops, harvests, and crop failure would have weakened populations potentially. That could have made a population more vulnerable to the spread of disease.